Section 13.1 Interactive Assignment Objective 2, Testing a Hypothesis Regarding 3 or More Means Using the One-Way ANOVA. The question states that by hand, determine the F-test statistic for the accompanying data by answering parts A through F below. First thing we want to do is we want to determine the mean of the entire set of data. So for part A, what we're going to do is, in order to calculate the mean of the entire set, we're going to do the following. We're going to take each of these values over here. So each of these values over to your right, each one of these, we're going to take the entire data set and then divide the total, which is 15. So we get 135 over 15, which is equal to 9. So the mean of the entire data set is going to be 9. Okay, now what we want to do is we want to find the sample mean for each sample. So what we can do is we can use StatCrunch for this because we're given the data. So if we take a look here, I'm going to open this up. Here is our data. We're going to go to Open in StatCrunch. And then what we're going to do is we're going to go to Stat, select Summary Stats, and select Column. And then we're going to select each column here. And then we're going to find the mean of each one. So we're going to compute, and therefore there is our summary. So let's take a look at that on this page. So here we did that following, and there is our mean. So therefore, the mean of data set 1 is 6. The sample mean of data set 2 is 9. And the sample mean of data set 3 is 12. Next, we want to do is we want to find the sample variance for each sample. So we're going to follow the same type of procedure. So I'm going to go ahead and then open this up in StatCrunch again. So I'm going to go to Options, and I'm going to Edit. And then rather than finding the mean, now I'm going to select the variance item. So I'm going to select Compute, and there is my data. So you can see here that I've copied it in here. So we can see that the variance, which is S squared for data set 1, is 35.5. The variance for data set 2 is 20, and the variance for data set 3 is equal to 33.5. Okay, so what I'm going to do here is I'm going to go ahead and then pull the data that we just had for both the sample mean and the sample variance. And so for part D, we want to compute the sum of the squares due to treatment, which is SST first. So that means we're going to take the sum of the sample size for each data set times the sample mean for each data set minus the entire mean of the entire data set. So let's go ahead and do that. So if we take a look here, we know that the value of n, okay, this is the sample size, right? So we know that the sample size for each data set is 5. Okay, and then what we're going to do is we're going to take the sample mean for each particular data set. So we know the sample mean for x1 is 6, the sample mean for x2 is 9, and the sample mean for x3 is 12. Okay, and then we're going to subtract the entire sample mean, and we know that the entire sample mean is 9. So now what we're going to do is when we do that, now we're going to go ahead and then calculate the entire thing, and we end up getting 90. Okay, so now we want to find the sum of the squares due to error, which is SSE. So the sum of the squares due to error is equal to the sample size minus 1 times the sample variance of each data set. So we know that the following. We know that the sample size for each one is 5. And we're going to be subtracting 1 for each item. And then we're going to multiply that by the variance. So the variance of sample size 1 here is 35.5. The sample variance for data set 2 is 20. And the sample variance for data set 3 is 33.5. So when we follow that order of operations, then we end up getting the following. We get the sum of the squares due to error is 356. So now we have our SST and SSE. Now we want to move on to computing the mean square due to treatment, which is MST, and the mean square due to error, which is MSE. So in order to find the mean squared due to treatment, we're going to take the value of what we found for SST and divide it by K minus 1. So K is how many data sets do we have. So we know that SST is equal to 90. How many data sets we have is 3, and then we're going to subtract 1. So that means we're going to get 90 minus 2, and so therefore we're going to get 45. Now we're going to solve for the mean squared due to error, which is MSE. So MSE is equal to SSE divided by n minus k. Well, in the previous step, SSE was equal to 356. Okay, the value of n is how many are in the total data set, which is 15. And we're going to be subtracting the value of k. Since there's 3 of them, we're going to subtract 3. So we get 356 divided by 12, and then that gives us the value of 29.67. Okay, now the last part, we're going to be able to compute the F-test statistic. So in order to do that, the F-test statistic is equal to MST and dividing it by MSE. So therefore, we're going to take the value of 45 to divide it by 29.67. And then rounding to 2 decimal places, we end up getting the F-test statistic to be 1.5